project is the Statius shin guard, Statius meaning innovated in Latin.
This project was done by Jillian Montella and Kristen Hune.
There are 5 major issues we found in a standard shin guard. These issues have not been seen as a priority by major companies making shin guards. These issues include the odor of the shin guard over time, having to readjust shin guards while playing, the amount of sweat produced under shin guards, difficulties cleaning them, and lack of cleanliness even after they have been washed. Also, discomfort has also been an issue for shin guards.
Our problem statement is that shin guards need to be improved in the aspects of their ability to stay in place, their odor over time, and their ability to be easily cleaned. These 3 issues are based on a local survey we conducted with about 80 responses. 84.4% of the responses said that they had an issue with their shin guards shifting, 63.6% said that odor is an issue, and 41.5% found cleaning to be difficult.
The reason we chose these 3 major topics to focus on is because, for one, odor is a common issue that is overlooked by companies designing new shin guards, and there are no solutions to this problem within the shin guard internally. The only solutions are externally. Also, sliding of the shin guard. Based on the survey that we conducted, over 84% of the soccer players have had issues with sliding and shifting their shin guards while playing. We made this a focus throughout the designing process due to the vast amount of people who have experienced this issue. Another major topic we focus on is cleaning, because a recurring problem we found with most of the shin guards is how difficult it is to clean them. Most shin guards have crevices on the padding that makes cleaning them very difficult, and there becomes grime buildup within the crevices.
The previous solutions we researched are as follows. The light guard is a moldable shin guard that becomes flexible when submerged in hot water. Although this is a very innovative design, this shin guard is expensive, made for professionals, and is not easy to come by. Additionally, this material may not be as strong due to the low temperature needed to soften it. The G-Form Pro S class shin guards, like many other standard shin guards, have many gaps and crevices on the inside of the padding. These gaps easily get filled with sweat, making it difficult to clean the buildup. Shin guard pockets. While shin guard pockets may keep the shin guard from shifting sideways, the weight of the shin guard can cause it to slide down.
While researching previous solutions, we found patents to the designs of the moldable shin guard and the shin guard pocket seen in these images. The D30 non-Newtonian material is a foam that is moldable and pliable, except on impact it becomes hard and shock absorbent. We planned to use this in our design, but we could not afford or have access to it. So we used a foam with similar qualities that was not quite the same.
We have 5 major prototype requirements. Neutralizing odors. The design must be able to neutralize strong odors from sweat buildup over time. Lessening sweat. The prototype must reduce the amount of sweat produced by the shin. Ease of cleaning. The shin guard should be easily cleaned without hard-to-clean crevices. Comfortable. It must be comfortable for the player to wear and not impede in their ability to perform. And stay in place. The shin guard must be able to stay in place without shin guard sleeves or other additional support other than a sock.
We each came up with 3 designs to try to meet the prototype requirements, and our designs were reviewed and rated on their ability to meet them. These seen here are Jill's 3 designs.
The designs seen here are Kristen's.
Here is our decision matrix, where each aspect of our design is rated on a scale of 1 to 5, with 5 being the best. The justification for these scores can be seen in this matrix as well.
Revised and final design concepts. 1. Inserting charcoal chunks in between the padding and the hard shell will decrease odor. 2. Loosely adhering nitrile to the inside of the shin guard will provide added grip to the shin even with added moisture. 3. Adding silicone to the outside of the shin guard will grip to the sock and reduce shifting in every direction. 4. There will be no gaps on the inside of the padding where buildup can occur. 5. Along with reducing the need to adjust, keeping everything a consistent thickness and adding a softer but thicker padding will make the shin guard more comfortable.
After testing some materials that we had decided to use in some of our designs, we created a final design that incorporated ideas from each person's designs. For example, we have the sticky silicone part of the shin guard on the outside so that it can stick to the socks, and the foam on the inside has charcoal within it to absorb smell, and there is a nitrile glove material on the inside of the shin guard to grip to the skin. All of these concepts come together to form our final design, which can be seen here.
These images show the inside and outside of our final prototype. On the inside is our foam padding with charcoal underneath. On top is the loosely adhered nitrile that grips to this shin even with water or sweat. Adhering it loosely provides grip by allowing it to stretch and form to the shin. On the outside you can see the silicone material that grips to the inside of the sock. We came across some difficulties when trying to adhere this material to the shin guard. After intensive testing, we found that creating protruding pieces of silicone and taping in between them to be the most secure option.
For the testing of our prototype, we tested it in action with a soccer environment, and we tested the force needed to move the shin guard out of the sock in the setup seen on the left of this slide. On the right of this slide, the ability of the shin guard to absorb odors was tested after a player used the shin guards and sweated on the shin guards. It was placed in a drawstring bag and sealed with the drawstring and left over time to see if there would be a smell buildup. The results of the prototype testing can be seen on this slide for the amount of max force needed to move the shin guard out of the sock. Our design took, on average, more newtons than the regular Nike design, as can be seen. In addition, for the soccer environment testing, the shin guards were placed in the front of the sock, and at the end of soccer activity, the Nike shin guard had shifted to the inside of the shin, whereas our shin guard stayed in the front of the shin. After the shin guard was used, there was still a lot of sweat buildup on our shin guard, but it is no different or no more than the Nike shin guard, as you can see in this picture. Also, the Nike shin guards have crevices that are very difficult to clean, and it caused this buildup over time, whereas our shin guard, as you can see, is just easy to wipe down like so.
Throughout this entire process, we used all 4 STEM concepts. We used science when measuring the force and friction of different materials, testing the shock absorption of our foam, and testing the odor absorption of the charcoal. Additionally, we did extensive testing on different adhesion methods to attach the silicone to the hard shell of the shin guard. For technology, we used Logger Pro, a software to measure force, different tools including wire foam cutters, cutting tools, and scrapers. We use engineering by utilizing the engineering process, construction methods for making our prototype, the problem solving throughout the build process. Lastly, we use math when measuring and coming up with dimensions and collecting data from our survey and various testing.